My name is Wei Xiaohuan.
My name is Paul Morrow.
My name is Gang Wang.
My name is Martin Schubert.
My major is electrical engineering.
I'm a PhD student in physics.
My major is chemical engineering.
PhD student in electrical engineering.
I'm coming from central part of China.
And I'm from Spartanburg, South Carolina.
I came from the northeast of China.
And I'm from Boston.
My parents are actually farmers. They own a small grocery store. So they are the generation who really never have a chance to go to college. They really believe education is one of the most important things for the best to support me and my sisters to go to college. Now I'm closing to get my PhD, so I hope I can make them proud.
My dad's been a college professor, recently retired for around 30 years, and my mom is actually still teaching. They created an environment where they didn't push me, but it was definitely an environment that allowed me to learn and be excited about discovering new things for myself. My dad always is asking me questions. In the middle of the day, sometimes he'll give me a call, and he loves his dabbling in investing, history, philosophy, and economics in general. So I love asking him questions.
My parents are just ordinary people. My mother was a nurse, and my father was a miner. My parents didn't go to a college, but they know the importance of education. Try to create opportunity to pay more to let me admitted in better primary school, high school. My parents are very proud of me. They talk to neighbors, about my achievement.
I was born in Germany and moved to the United States when I was 3. Originally, I lived in New Jersey, and that's where I was up until about the 7th grade. Then I moved to Boston. In high school, my math and science teachers were very inspirational to me. So my advisor is my father, actually, Professor Schubert. My father and I have a great relationship. We work tremendously well as a team, and that's what I knew before I came here, because I knew that together we would be able to accomplish great things.
I invented a new gallium nitride MOS process and also several new MOS structure for the purpose of the power switch applications. It's really opened a new door for a lot of applications which we might even don't know right now. One company which is cooperating with us is Toyota to make the whole system more efficient in a hybrid car, in the motor drive, in power supply, high voltage devices. I think this invention will be smaller than the conventional silicon devices. We want to integrate everything into one chip, less weight and less volume, higher efficiency, higher power density, consume less power, can use in a higher temperature, up to like 300 degrees C. And also very importantly, it's simply cheaper.
My project, briefly, is involving 2 different fields of study in nanotechnology. The first is thin film deposition, and the second is scanning tunneling microscopy. In oblique angle deposition, you tilt the substrate to a very high and glancing angle so that the flux comes in very obliquely on the surface. Instead of getting a uniform coating, you get a nanostructured film composed of small tilted nanocolumns. Instead of using a single material to make these nanocolumns, I use very thin layers of a ferromagnetic and then a non-magnetic material. The reason why this system is interesting is because in other studies it's exhibited giant magnetoresistance, which has already found a wealth of applications in the magnetic field sensing and recording media industry. The second part of my work is using a scanning tunneling microscope that's built of non-magnetic parts so that it can operate in a magnetic field. I use that microscope to contact the top surface of a nanocolumn film. I can measure the resistance of that small contact and of those small nanocolumns in an external magnetic field, which provides a way to measure the giant magnetoresistance of these structures. It's a very unique system that's exhibited GMR.
My research is about rationally designed porous catalysts that have vastly superior performance and can easily be synthesized. I invented a new design for porous catalysts. I think my invention will make existing chemical processes more efficient. This new design uses less material but give a better performance. Catalysts are so widespread in industry. I think the impact of this design will be far-reaching because catalysts are also used in applications for environmental protection. For instance, catalytic converters are used to control emissions from cars, wastewater treatment, for power plant emission control. If we can use efficient catalysts in those processes, we can, of course, protect our environment.
My research deals with polarized light-emitting diodes, which are interesting for many applications such as backlighting for LCD displays and free space optical communications and imaging and sensing. Before my invention, there was no practical way to make a polarized LED. And through my innovations, we have discovered a way to do it, and we've also actually demonstrated polarized LEDs. Polarized LEDs could lower costs for manufacturing and for operation because the LEDs are more efficient, the backlight is more efficient. So with fewer LEDs, you can have the same amount of useful light. If we have LED lights instead of incandescent lights, we can save energy by a factor of 10 while keeping the light output the same. And this would have a tremendous impact on the energy consumption nationwide and worldwide.
I think the reason I like this research is I'm always curious about how things work and try to find out why.
I've always been, I think, an experimentalist ever since I was young. I like taking things apart. This included taking apart a lot of my mom's cassette recorders, which didn't usually work when I was done.
I like research very much because there's always something new you can try, you can explore. It's very abstract, but to me it's fun, I like it.
What I like about research is the challenge that it offers. There's no road to follow, no specific list of instructions. You have to find your own way. You identify a problem and then come up with a solution on your own.